Hello everyone. In today's video, we are going to talk about the series and parallel combination of resistors. But before that, I would like to tell you that while learning, there may be mistakes, but you should not give up. You may not be able to solve a question, or you may not be able to understand a question, but never quit, because quitting is not an option. Do the mistakes, waste 2 3 pages, take some rest, and come back. Again, start solving. Waste 2 3 pages. Don't hesitate to pay to waste the page or to cut and to strike out the full solution, because learning begins from improving on the small mistakes. When you are solving a question, it's possible, and it's quite possible, and I must say there are a lot of mistakes which you are going to do, but do not hesitate. Do those mistakes, but never give up. So keeping that in mind, I'm not going to edit this video. I will solve all the questions in front of you here without editing anything, or without copying and cutting or pasting anything from this part to that part, because we as a teacher also do mistakes. And while solving, sometimes we do not get a solution of a problem, and that's completely fine. Okay, because all the problems, they do not, uh, most of the problems, I must say, not all the problems, but some of the problems are so complex that they do not have the known solution yet. We may know in future. So no one in this world knows all the solutions of all the problems. Okay, and you are a student, you are learning. So on that note, let us discuss about the series combination of resistors. So series combination of resistors. So you may be already aware of what is a resistor. A resistor is an electrical component which opposes the flow of current. So let us assume that this is a resistor A, and this when current flows through this resistor, the electrons are opposed to flow through this resistor. Okay, so when the electrons are opposed to flow through this resistor, their motion reduces, and when their motion reduces, of course the current flowing through the resistor and in the entire circuit in which the resistor is connected reduces. Okay, if there are many resistors, let's say this is a resistor B, and this one is a resistor C, and if they are connected one after the another means something like this: A, then B, then C, but still it's not a series circuit. Let me complete it. So here A is connected to B, B is connected to C, and the last end of C is open, and the first end here, this end of the resistor A is also open. Okay, so this is called as a series combination of resistors, but it may not be clear to you. Let me explain you in a better way. So what I'm going to do, let me change the color of this pen which I'm using. Now this is a blue color pen. See, I was saying about the mistakes and the challenges which you will face, and right now my pen is not working, but I'm not going to stop. I'll wait for some time, and I'll see why my pen is not working. So yeah, I think it's working. Yeah, it's working, only the color is not visible. So let me change the another color. Yeah, so this is end 1 of resistor, let's say, and this is end 2. This is one end 1 of resistor B, and this is end 2. Similarly 1 2. Now when end 2 of resistor A is connected with end 1 and end 2 of resistor B is connected with end 1 of resistor C, then this is called as series combination. So what you can see, only one end of resistor 1 or resistor A is connected with the other end of resistor B, and the other end of resistor B is connected with the next end of resistor C. This is series combination. Now if you imagine, if you're holding this end 2 of resistor C and end A end 1 of resistor A, and you're trying to stretch it, then this combination would look something like this, right? So this is called a series combination. Sometimes students, they get confused after seeing the combinations, something like this. Okay, this is resistor A, and this is resistor B, and this is resistor C. Okay, and they are connected something like this, 1 and 2. And if I ask you whether it is a series or parallel, many of you will say that it's a series, but some of you may say, oh, it's a parallel, because see, the resistors are stacked over one another. But no, if you stretch it from this end and this end, you will find this is forming a series something like the above one. So this is series combination of resistor. Now, in series combination of resistor, there are some some characteristics which we can say we need to understand. And what are those? First of all, in series combination, when the resistors are connected like this, so whatever current flows through one resistor, same current will flow through the other resistor. Let's say this is I current which is flowing through resistor A, same current will flow through resistor B, same current will flow through resistor C, and same current will flow through resistor any other resistor, right? But it should be in series. All right, now let us connect a power supply to show that there is current flowing in the circuit. Yeah, so this power supply, it could be a cell or a battery of EMF epsilon. This battery is pushing the charges through this resistor, right? Now, the other important thing is the voltage across each resistor may or may not be different. Okay, so let's say this one is having resistance voltage, not resistance, it's the resistor is having, let's say, resistance RA. So voltage across the resistor A can be VA, and the voltage across resistor B could be VB, and the voltage across resistor C could be VC, right? And let's give the variable value to these resistors, and let's say that resistance is RC, and for this one it's RB. So what you can see here, resistor A is having voltage VA, resistor B is having voltage BB, and resistor C is having voltage VC. But the total voltage across A, B, and C is going to be epsilon. Okay, and epsilon is equal to VA plus VB plus VC. It means combined voltage across A, B and C is going to be equal to epsilon. Right? Now, when I say the voltage is equal to epsilon, I'm assuming that the internal resistance of this cell is 0. And if you don't know what is internal resistance, don't worry about that. We can discuss later on about the internal resistance in any other video. Okay, since we have epsilon is equal to VA, VB and VC, what we can do is we can use Ohm's law. Use Ohm's law. What is Ohm's law? Ohm's law is V is equal to IR. V is equal to IR. And because current which is flowing in this resistor is I, here also I, here also I, and each resistor has a resistance RA, RB, RC respectively. So what I can do is I can write VA is equal to IRA, right? I can do that. And here VB is equal to IRB. Similarly, VC is equal to IRC. Correct? Now you may be getting some idea what we can do with this VA, BB and VC. So I can take this VA, substitute its value here, VB and substitute its value here, and VC substitute its value here. So I can write VA, or instead I can say epsilon is equal to VA plus VB plus VC is equal to IRA plus IRB plus IRC. And finally, we can write epsilon is equal to I can take common because it's common in all. So I can write RA plus RB plus RC. One more step here, and we can write it as epsilon by I is equal to RA plus RB plus RC. If you know Ohm's law, and we have already written here epsilon V is equal to IR. So what we can do here, we can write V by I is equal to R. It means, sorry, I'm writing here epsilon, but I have to write here I. So V by I is equal to R. Similarly, I can write epsilon by I is equal to R. So here, in place of this, I can write R is equal to RA plus RB plus RC. This is the formula of series combination of resistors. And you know, after seeing this formula, that the overall resistance of all the resistors is getting added in series combination. It means if you are connecting these resistors in series, add their resistance simply. Right? Let me create the another page so that we can go to the next page. I'm here on the next page, and you just learn the formula of series combination of resistors. But now we are going to learn about the parallel combination of resistors. So parallel combination of resistors. So in case of parallel combination of resistors, first of all, how it looks like, let me draw a circuit diagram. So first of all, take three resistors again, A, B and C. So in these three resistors, let's say I'm connecting the ends of resistor A and B, something like this. Okay, and if you remember, I had given it a name, end 1, end 2, end 1, N2, N1, N2. So now end 1 of resistor A is connected with end 1 of resistor B. And the end 2 of resistor A connect with end 2 of resistor B. And again, end 1 of resistor B connected with end 1 of resistor C. Similarly, this end also with end C. Now, when both the ends of resistors are connected with both ends of any other resistor, then that combination is parallel combination. Okay, now to make this circuit complete, I have to take the connection out to connect it with a power supply. So here I connected a wire with a power supply, right? Let's say like the other circuit diagram in series combination, this one is also having the EMF epsilon. So EMF of the circuit is epsilon, and when the charges start flowing, they will come here at this junction. Let's say this junction is anything, I can say junction X. When they reach at junction X, they have three possible paths to flow to flow. Who has three possible paths? These charges which are coming in the form of current. So the current splits into three possible paths, and the current which is splitting, it may or may not be equal. So this one may have current IA, this one may have current IB, and this one may have current IC. But please do not get confused that they will always be equal. Splitting may be, and when they split, their value may be less or more. Okay, or sometimes if the resistance is too high, the current in one of the component may be negligible. But overall, one thing is true. And what is that? Whatever current is entering at point X, that will get divided among these three lines, and IA plus IB plus IC will be is equal to I, right? So what you can see here, the overall current entering into the junction is equal to the overall current leaving the junction. Now when current I reaches here, it will produce some voltage across this resistor A, and let's say that voltage is VA, correct? I can give the same voltage VB here, like I gave in the series combination of resistors here, VB, and let me write it. I'll explain you later what is happening here, VC, right? So what you can see here, VA, BB, and VC, they have the they have the voltage uh, across A, B, and C. But the thing is, just do the analysis of this circuit carefully, and you will find re, resistor C is directly connected with the power supply here, like this. When resistor C is directly connected with the power supply, it should get maximum EMF. So VC should be is equal to epsilon. And if I see resistor B, the resistor B is also directly connected with the power supply. So why it should get different voltage? It will get same voltage as of the power supply. So I can write here VB is equal to epsilon. Similarly, here we resistor A is also connected directly with the power supply, though its wire may be a little bent, okay, or it may be a little far, but far doesn't matter here because we are assuming that the resistance of the connecting wires is 0. So VB is getting epsilon, VC is getting epsilon, so VA should also get EMF epsilon, correct? So what you can say here, the voltage across all the resistors is parallel. Not parallel. Voltage across all the resistors in parallel. Let me correct here. In parallel combination is same, right? So when the voltage is same, we can write here this formula first of all, which we have written just above this line here. I can write I is equal to IA plus IB plus IC, and from Ohm's law, what I can write? I can write V is equal to IR, and I is equal to V by R, correct? And here we just now said voltage is same across all the resistors, okay? So I can write, first of all, just to show you, I can write IA is equal to VA by RA, but we know VA is equal to epsilon, so I can write epsilon by RA. Similarly, IB is equal to epsilon by RB, IC is equal to epsilon by RC, correct? So what I can do is I can substitute these values like we did in the last equation, something like this, here and here and here. So I can write I is equal to what? Epsilon by RA plus epsilon by RB plus epsilon by RC. Okay. Now, like the previous question, and let me create a new page first. Like the previous topic when we were studying the series combination, what I can do, I can take epsilon common. So epsilon 1 by RA plus 1 by RB plus 1 by RC, right? Let's take epsilon towards this side. I can write I by epsilon is equal to 1 by RA plus 1 by RB plus 1 by RC, correct? Again, I have to bring the Ohm's law here, and we know Ohm's law, epsilon by I is equal to R. So take the reciprocal of this. I can write 1 by R is equal to I by epsilon. So here we can write 1 by R is equal to 1 by RA plus 1 by RB plus 1 by RC, right? So this is the formula of parallel combination of resistors. Okay, so what we got here, the formula, we got 1 by R is equal to 1 by RA plus 1 by RB plus 1 by RC. Now, when you will solve a equation related to parallel combination of resistors, so in that case, after getting the solution, to actually find the value of resistance R, you have to take the reciprocal of the value 1 by R. Otherwise, sometimes students, what they do, they find the resistance something like this. Let's say 1 by R is equal to 5.8 ohm. And finally, in any other formula, which is, let's say, RA is equal to R B plus RC plus RD. What do they do? They substitute this value directly here in place of RC or in place of RD or in place of RB. And that is where did they do the mistakes. No, you should not. Instead, what do you do? First of all, this should not be ohm here. Why? Because it's a value of 1 by R. Okay, so it's an ohm inverse technically. So what you're supposed to do? You are supposed to take the reciprocal of this value. It means you have to write R is equal to 1 by 5.8. Now simplify it and substitute here or here or here, and you will not be wrong. Okay, so do keep that in mind before substituting into next step. So let us come to a numerical, and let's say a simple numerical is for series combination, and that is something like this: resistor 1, resistor 2, and the other resistor 3. Okay, 1, 2, 3. They are connected with one power supply. Okay, tell me, is this series combination or parallel combination? First of all, it's a series combination. Don't go on the shape. Okay, so here, let's say the power supply is having a voltage of 12 volt, and each resistor is having a resistance of 5 ohm, 5 ohm, 5 ohm. So what is total resistance? Total resistance in series form would be 5 plus 5 plus 5. Very easy. So we got 15 ohm. Now someone asked you, instead of asking the total resistance, they asked you what is the total current flowing in the circuit, or what is just the current flowing in the circuit, and you got confused here. No, don't get confused. The simple thing you can do, Ohm's law. Use Ohm's law. And what is that Ohm's law? V is equal to IR. Right? And now, what is V? V is 12 volt. 12 volt. I need to find. And R is how much? 15 ohm. So I is equal to 12 by 15. Now, what is value of 12 by 15? I need to calculate with the help of my calculator. So I'm using mobile. Just one second. 12 divided by 15 will give me 0.8. So the current in the circuit is 0.8 ampere. What is unit of current? Ampere. So let me create another page. And now I have created another page, and let's take a parallel combination circuit. So when I'm taking a parallel combination circuit, something like this. So this is a 12 volt power supply, 5 ohm, 5 ohm, 5 ohm, and 5. Each resistor is of 5 ohm. So first of all, you tell me what is its resistance, the overall resistance of the circuit. And not RA, I should write RP, the overall resistance of this circuit. What would be the value? Got confused? Okay, don't get confused. First of all, these two resistors 1 and 2. If you see, their end is connected one after the another, so they are in series. So what is their total resistance? So total resistance of 1 plus 2, what it should be? It should be 10 ohm. Similarly, let's say this is resistor 3 and this is resistor 4, and they are connected in series. So resistance of resistor 3 plus 4 is how much? How much? 5 plus 5 is equal to 10 ohm. Now, to solve this, you can draw another simplified circuit, and it will look something like this. So one resistor of 10 ohm on the top, one resistor of 10 ohm at the bottom of the combination. So this is now 10 ohm resistor, this is now 10 ohm resistor, and they both are connected with a power supply of 12 volt. Hello, they are connected with a power supply of 12 volt. Now if you see, the question is quite clear. Two resistors of 10 ohm each are in parallel combination. So what I can write? 1 by Rp is equal to 1 by 10 plus 1 by 10, which will give me 1 plus 1 by 10, right? Now, if you take the reciprocal, first of all, let me write it in one more step. So I'm getting 2 by 10. You think this is the answer, and sometimes what you will do, you will take this value in a hurry and you will put it in the solution, and here you do the mistake. Just one more step, take the reciprocal so that you get Rp is equal to 10 by 2, and Rp is equal to actually 5 ohm, right? This is how you solve series combination question and parallel combination question. I'm going to create more video based on series combination and parallel combination of resistor. Till then, you use your textbook, practice some questions, and prepare mentally, and then watch my next video. Thank you for watching, and subscribe to this video so that we can connect easily with each other, and I may be able to help you in a positive way to make you learn something. Thank you.